So today's topic is solubility, and it's really required in chemistry in all aspects, in all reactions. This concept is very important. I have made this topic continuous with the chapter Group 2, so this will fall under the Group 2 topic. So the solubility of Group 2 hydroxide increases down the group. Hence the basicity, the solution get more alkaline. So if the hydroxides are more soluble, they are more dissolved in water. So there is more OH minus ions in water. And like if you go down the group from barium down to radium and there is more OH ions, what it means is more basic. So, however, the sulfates gets less soluble. So this is only specific for group 2, but let's have a general look for this at a solubility table. So I found this table somewhere, and I find this more easier than any other ones. So first look at this is the soluble parts, and these are the exceptions we have for those things. So first we have for soluble we have group 1 elements, which are the lithium ions, sodium, potassium, etc. Then we have ammonium, any element or compound containing. So there are no exceptions if you see, like anything containing ammonium, for instance, NaH, let's say NaH4Cl. So anything containing ammonium, it will be soluble. Instantly we can say that it's soluble. And it's more easy to say that there is no exception here. Similarly, the same for nitrate. There we can see an exception. However, uh, if you move on, there are more things that are soluble. So we have not the carbonate, but the hydrogen carbonate. The one thing you have to remember is carbonate itself is insoluble. Only the hydrogen carbonate is soluble. So moving on, we have chlorate and this thing and the halogens. So whenever you see there is a halogen, anything containing, uh, for instance, NaCl, so this should be what? This should be soluble. Anything that you see is containing halogen should be soluble. However, it has some exceptions. For instance, gold and no, sorry, silver. We have lead and we have mercury. So these are the exceptions. It can be that Ag and Br, and you can't have, uh, and that should be insoluble. So that should be solid. You can write aqueous. So moving on, all sulfates are soluble. So this, can you see this? That these two are repeating, like this silver and lead. So you should be careful whenever you see these two elements. You should have a second look whether it's a halogen or sulfate is attached to it. So it will be insoluble. So all sulfates are soluble, and also, but the sulfates cannot have group 2 in them. That's a good exception. So you can't have Ca SO4 that is soluble. So you can't have group 2s from calcium to barium. So have a look at this. And moving on to the insoluble, uh, the insoluble salts. So firstly, we have hydroxides. So in previous reactions, we were seeing uh, metal oxide or metal itself. When they react with water, they usually form hydroxides. So they are usually insoluble. They were supposed to be, they're, anything that's reacting with OH and any compounds that we have OH in. So that's supposed to be uh, like, let's say it's NaOH. So it was supposed to be solid, but it has some exceptions, which is the group 1 and group 2 elements only. So these exceptions are the ones which makes the thing catchy and a little tough, but rather than those, it's actually very easy. Moving on, we have chromate. If you see any chromate ions, uh, it's you can first say it's insoluble. Then if you see something like if group 1 elements or group 2 elements is attached to the chromate, these are the exceptions, it will be soluble. Similarly, carbonates and phosphates and sulfite, these three ions can also make things insoluble. Exceptions are the group 1 and the ammonium. I mean, see, ammoniums are here also. Like anything containing ammonium with this will make it soluble too. So firstly, I said that anything ammonium containing will be soluble, and there is an exception. So everything is insoluble except something containing ammonia, and usually something like if you want to remember and not forget, uh, you can just remember that group 1 elements. You will just look for group 1 elements, whether, yeah, I put it here also, I mean the soluble table, that anything containing lithium, sodium, potassium, I mean the group 1 stuff will make it soluble. So be careful when we have this can make this can make the insoluble stuff soluble, as well as some group 2 and always the ammonia. So moving on, so we have element KBr. So find whether this is soluble or is this aqueous. So how do you do this? So look at the second element, look at these. So Br, we said what? Br, or the halogens, are always soluble, but you gotta look for the exception. If we have silver, lead, or mercury, it can make it insoluble. So if we check, it is not bounded to any of those sodium, I mean the silver or lead or something. So this is actually soluble, so it's aqueous. Moving on to AgCl. So Cl is a halide ion. So it's this. So first check this. The step 1 is the second element is soluble, and we see it is soluble, yeah, because it's a hydrogen. But if you see that now the step 2 is checking whether the element attached to it is an exception or not. So we know Ag is an exception, yes. So this won't be a soluble. This would be insoluble, and it would be a solid. Moving on, we have I2. So we know that halide ion, all halide ion are soluble. So we first consider this element, I mean this compound, to be soluble, and then we check whether this is an exception or not, and we find that this lead is actually an exception for the halide ion. So this is also solid, not a aqueous compound. So moving on, we have nitrate. So we know all nitrates are soluble, and there is no exception. So whenever you see nitrate ion, you just write it's soluble, and we don't have to check because there is no exception for nitrate ions. Similarly, uh, there are other things, I mean that's how you check actually. So that's it for solubility, and we shall see you next class. Goodbye.